Hey guys, this will be the 4.3 homework assignment. So we have we're just graphing radicals or radical functions. Um, so let's just go ahead and graph this. We should recognize that the behavior of the square root function, is essentially the behavior of the x squared function, but just on its side. So if you think about x squared looks, if you remember the 135 rule, of x squared, where you have a point at the origin, you go up 1 over 1, then you go over 1 and up 3, then you go over 1 and up 5. You're going to follow that same sort of behavior, but instead you're going to use it in the x-axis, like that right there. And we're only going to be using the upper half, the positive values. And so when I see square root of 5 minus 5, that's also a transformation though. So minus 5 means, well, let me just draw the parent square root function. So that's going to be here, so up 1 and over 1. Then I'm going to go up 1 and over 3. Then I'm going to go up 1 and over 5. So 1, 2, 3, 4, 5. There we go. So this is the parent function of the square root function. Sorry. And we have a transformation that's going to be down 5 units. And so if you graph this same function, but we just move it down 5 units, that's what this function will be, right there. And so we're also identifying the domain and range. So as I look at the x values, so the x values they go as low as 0 on the x-axis. They go as low as 0, and they move and they keep going. And so for the domain, it's going to be x is greater than or equal to 0. For the range, for the y values, we go as low as -5, and then we're just going to keep going up and up. It's going to grow at a slow rate, but it's still going to, the y values are always going to increase. And so we're going to say that y is greater than or equal to -5. Okay, here we have the square root function, but this time it's going to be moved up 4, and so I'm going to put the first point here, and then I'm going to use the 135 rule just on its side. So 1, 2, 3, 1, 2, 3, 4, and 5. And so there you go. Domain, for this one, still x is going to be greater than or equal to 0, because that is the lowest x value, and it keeps increasing on the x. And then the range, the lowest y value is 4, and then it keeps going up, and so we'll say y is greater than or equal to 4. Okay, for 3, now this is a cube root, and this is a cube root right here. So cube roots will follow a similar pattern as x to the power of 3. X to the power of 3, so x to the power of 3, if you don't remember from last unit, kind of looks like this right here. So that's x to the power of 3. The cube root is going to be the same thing, but it's just going to be on its side, so it's going to be more like that right there. Rotated, I guess you can say, or not really rotated, yeah, kind of rotated, yeah. Okay, but we do have two transformations here. This is going to be moved, shifted to the left 6, and so the point that I would put here, well, let me graph the parent function first. So the parent function for the cube root of x it's going to look like this. So that's what it's going to look like. So the reason being is because, well, I kind of said how it's like the inverse of x cubed, but also if you just think about, so if we think about the cube root of x, think about numbers that are perfect cubes. So when x is equal to 1, the cube root of 1 is 1, right? And then the next perfect cubed would be 8. So when you get the cube root of 8, so if this were 8, that would be equal to 2. So if x is equal to 8, then that's where it's going to be equal to 2. And that's why whenever you get negative 8 in here, the cube root of negative 8 is going to be negative 2, which is why you get that point right there. And so it's just behaving the as you would any cube roots. So that would be the parent function given here. And then this means we're going to move it to the left 6 units. And so take this right here. We're going to move it to the left 6 units like that right there. Okay. And then we also have a shrink by 1/2. So that means that instead of this distance and this distance here being 1, it's going to be shrunk by 1/2. So I'm going to bring that in by a factor of 1. Now, I'm also going to, so if we think about this right here, so over 1, up 1, and then if I go over another one, that's going to be 1, 2, 3, 4, 5, 6, 7. Yeah, perfect. So right here. Now, this point right here, which would be on the parent function, if we shrink this distance by 1/2, then that would end up being right here. And then this right here would be like that. And so to graph this function, that's what it would look like. So this is moved, shifted to the left 6, and a shrink by 1/2. Domain for these types of functions for cube roots are all real numbers. There's no minimum and there's no maximum. It just continues left and right. As for the range, also the range, it's just going to keep growing in the y direction, in both positive and negative y direction. So the range is also going to be all real numbers. All right, for 4, so I see 3 transformations. I see this right here. Now, just because it's raised to the 1/3, just remember that this is the same thing as -3 cube root of x plus 1. And so it's still a cube root function, but so I have a reflection in the x, so meaning that it's going to behave like this rather than how it normally does, because that's a reflection in the x. It's going to be stretched by 3, so in this one right here, we shrunk the values by 1/2. This time they're going to be stretched by a factor of 3, and then it's going to be moved to the right one. And so I'm going to move it to the right one first, so that's going to be right here. And then the reflection would make it, so I'm just going to draw it without the stretch for a second. So like this right here. So now if the next point over is going to be 7 units, so 1, 2, 3, 4, 5, 6, 7, so that would put it right here. And then it would be 7 units that way, so that would just be off our graph, but we can still, so 1, 2, 3, 4, 5, 6, 7, so at 9, so that's where we can put it there. Okay, and then, so this is what the graph would look like before the stretch, but I did do the reflection, and I did move it to the right one. I need to move it to the left one, don't I? Yes, I sure do, because it's plus, so I need to move it to the left one. There we go. So that right there is kind of in the wrong spot. It would be right, whoops, not even right there, it would be right here. Okay, now as for the stretch by 3, so this point right here, is now going to be stretched by a factor of 3. So instead of being 1 unit away, it's going to be 3 units away. So that would be right here. Okay, that's going to be same for this one right here. So that would be right here. And then this right here, instead of being 2, it's a 1, 2 distance away from the x-axis. It's now going to be stretched by a factor of 3, so that's going to be 6 units away. So that should be like right there. And same with this one right here. It's 2. It has a distance of 2. We're going to stretch that to 6, negative 6 right there. So our function is going to look, oops, it's going to look like this. Like that. And there you go. Alright, looks like we have a couple more. So describe the transformation and then graph each function. So the square root of x over to this, so that would be a stretch by 2. And right 1. And then we're going to have, well, I'll get over to that. I'm jumping ahead. So those are the two transformations here. Let's first graph the square root of x. So that would be here, 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 and there. So that, whoops, not there, here. So that'd be 1, 3, and 5. Okay, and then so that's what it would look like right there. So we're going to move this to the right 1. So I'll just gonna, how do I want to draw this? I'll just move it to the right 1. So like starting right here, I'll move it to the right 1. Now this point would also be moved to the right 1, but now it's also going to be stretched by 2. So it's going to be moved to the right 1, but now it's going to be stretched by 2, so I'm going to put my point right here. This point right here will be moved to the right 1, but it has a distance of 2 from the x-axis. It's now going to have a distance of 4 from the x-axis. This is going to move to the right 1. It has a distance of 3 from the x-axis. It's now going to have a distance of 6 from the x-axis. So it's going to look like that. Okay. All right. Let's try 6. So we have the cube root. Let's go ahead and graph that. So I'm gonna put a point here, and a point here, and then at 8, it's gonna be up 2 because that's the cube root of 8. The cube root of 8 is 2. That would make it 7 distance away from this point right here. That'd be the same thing over here, 7 distance away from that point. Okay, and so this is what that's going to look like right there. Okay, the transformations are going to move to the left 4 and down 5. And so just think about these points. So left 4 and down 5, so maybe like right here. And then same with the other points. This one, down 5, left 4. I already moved this one, so 1, 2, 3, 4, 5. 1, 2, 3, 4. And then this point right here, so 1, 2, 3, 4, 5. 1, 2, 3, 4. So 4, negative 3. So just like that. Okay. Alright, and just remember that x to the 1/3 is the same thing as the cube root of x. Okay, so the cube root of x, oh man, I don't really have a bottom half to graph this for, but 1 and 1, and then at 8 it's going to be at 2, so that's what it would look like. We have up 6, so up 6, and we have a shrink by 1/3. Now I'm gonna go ahead and do the shrink by 1/3, I guess, first, and then I'll move everything up 6. But so this distance is going to be shrunk by 1/3, and so rather than being up 1, it's only going to be up 1/3. So maybe like right here or something. Up 1/3, maybe like, yeah, like right there. This distance right here is 2. And then if I shrink that by 1/3, you can just think about 2 times by 1/3 is going to be 2/3. And so that's only going to be like, maybe like right up here. That's only 2/3, right? So you can do that right there. And now I'm going to move it up 6. And so move these points up 6. So right here. And then 1/3 from there, and then probably like right there, and then I'm just going to mirror these points right here over on this side right here. So over 1 and maybe down 1/3, and then over here maybe down like 2/3. So yeah, maybe something like that. That's a hard one to graph, but that's what it would kind of look like, I guess. Okay. Okay, here we have a fourth root. Fourth roots are going to look a lot like square roots, okay? And so let's think about this right here. So we have down 4. We have right here, that's going to be left 5. And then a stretch by 2. And so for this one right here, so because it behaves a lot like the square root, let's just, first of all, I don't know why that's not there. Let's graph the parent function. So let's graph the fourth root of x. So that's going to have a point here, and it's going to have a point here. Oops, this is counting by 2, sorry about that, but over 1, up 1. And then if you think about fourth roots, so you can take the fourth root of 1, and then you can take the, 2 to the 4th power, it would be 16. So that would be like kind of way up here. Oh man. Let's just say 4 units over. So at 16, I guess you can say, it's going to be at 2. So this is what the graph's going to look like for x to the 4th. And then we are going to move this down 5. Or down 4 and left 5, so we'll put the point right here. And it's also going to be stretched by 2. So this distance right here, which is 1, is now going to be stretched by 2. So that's going to put it right here. And then let's move it down 4. So 1, 2, 3, 4. And over 5. 1, 2, 3, 4, 5. So 4, -2. Okay, and then the other point to graph right here, remember that we're going to stretch this by 2, so instead of this being a distance of 2, it's going to have a distance of 4, okay, and we're going to move it down 4, so if I move that down 4, that would be on the x-axis, and if I move it to the left 5, that would put it at 11, so that would put it right here. So there you go. That's what the graph would look like. All right. Moving on. So we're going to be writing rules. So let G be a reflection in the y-axis. So that's the first thing that we're going to be doing. So G of x is going to be equal to 2 cube root negative x minus 1. So I'm replacing that x there with the negative. Okay, and then followed by translation 1 unit to the right. So if I do 1 unit to the right, that's going to be x minus 1. So I'm subtracting 1 from just the x. And now you got to be careful with this step right here. Very careful with this step, because I already have a negative with this x, but I'm also subtracting 1. But that still doesn't change the fact that I'm only going to subtract x from 1 from the x. So that's what it's looking like. So to only subtract 1 from the x right here is that I'm only going to subtract it from the x. Okay, and then I can clean it up though afterwards. So I can think that I can distribute that negative. So it's going to be equal to 2. We're going to have the cube root of negative x plus 1 minus 1. And the good thing here is that now I have like terms in here, so it's going to be equal to 2 cube root of negative x. I wonder if we can even go as far to simplify it more and call this negative 2 cube root of x, because I don't think it really matters if it's there, but I guess it's fine. Alright, for the next one, let g be a translation 1 unit down. So we're going to take our function, negative 1/2 fourth root of x plus 3/2, and we're going to subtract 1 from it. Now I can combine these right here. So 3/2, which is 1.5, minus 1, that's going to turn it into 1, or just 0.5. So this is negative 1/2 fourth root of x plus 1/2 when I subtract 1 from that. And then we're going to move it to the right 5 units. So negative 1/2, we have the fourth root, and that's going to become x minus 5, I believe, plus 1/2, and then followed by a reflection in the x-axis. So that means I'm going to have to multiply this by negative 1, which means that this is going to distribute to here and to here. So my final expression is going to be 1/2 fourth root of x minus 5 minus 1/2. And there we go. Alright, for 11, write a rule for g that represents the indicated transformation. So, so we have f of x here, we have g of x here. So what we're going to do is do negative f of x, then we're going to add 9. So first of all, we're going to make times by negative. So that means g of x is going to be equal to negative 1/3 square root of x plus minus 1, and then plus 9 afterwards. So I think that's all we're doing. So first we make f of x negative, so we're going to make this negative. That's a reflection in the x-axis. And then we're going to add 9. So there you go. And then for this one right here, we're going to first do, we've got 3. So we got the shrink by 1/4, reflection over the y-axis, and then add 6. So let's first do the shrink by 1/4. So that just means that it's going to be 1/4 times by the cube root of x squared plus 10x. And then we're going to do negative x, which means right where I see x, we're going to change those to be negative. However, that being said, we've talked about this in our last unit, is that if I plug in negative x into x squared, that's going to stay x squared. That's not going to be the case here, so if I plug in negative x here, that's going to multiply to be negative 10x. Okay, and then plus 6, I'm just going to plus 6 right there, and there you go. That would be the finished rule for that right there. Okay, and that's going to be everything for 4.3.